Okay, day 52, and I'm going to start off with a retraction and an apology. Yesterday, or last day, I said that it was a double lesson, and it's not a double lesson yesterday. I suppose you figured that out in class. This is the day 52 lesson. In fact, we did one section in the textbook over 2 days, and that, 6.1a was day 52 or day 51, and now we're doing our second day on day second day of 6.1 on day 52, and it's quite, today's lesson is quite a bit more challenging. So let's get right into it. Last day we were doing formulas that had to do with roots, and so we've got an example here: 100-watt light bulb, resistance is 144 ohms. What's the voltage? Now notice that I don't know anything about electronics or electricity, but I can figure out the formula by looking at the units here. So which is V, which is P, which is R? Well, I can do that by the units. There's a formula, and formulas we're okay at. V, P, and R. 100 watts. Well, watts is P, right? So that's 100 there. Ohms. Ohms is resistance, so this is 144. And so it must be the voltage that we want to find. And P is 100, the resistance is 144, and then you can fire that into a calculator, I believe, and you get 120, and voltage is in volts. And that's the sort of thing we were doing yesterday on our calculator and without a calculator. Okay, here we go. 6.1 formulas part 2, and these problems are quite challenging. Very similar to problems that we did back in the measurement unit. The measurement unit was unit 2, where we did all the surface area and volume problems, and these kind of fit in there, but more challenging problems, and we're going to use some algebra. So the example is Mr. Elief is making pastries to sell for a fundraiser before Christmas. The batter is class 3/8, fills a tub, that's blah, 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 measurements. The batter must be rolled into dough balls that are 1 inch wide and then deep fried. If pastries are sold for 50 cents each, how much money will be raised? This is just, this is a lot of information. We can sort of start planning and stuff like that. But this is pretty hard, right? There's lots of steps. And perhaps we should have done this back in the measurement unit, but I'm going to introduce a problem-solving strategy that'll help us get organized on these tough questions. And some of you will be familiar with this if you had Miss Lickby in grade 10 or 11 or even grade 9. You've done this before, and I know other teachers at Northwestern also do it. And it's kind of a way of getting organized in these tough problems, or any problems for that matter. And it's the GRASS technique. And so the problem-solving framework is called GRASS. And so in this, we've got a G stands for given, state what's given. R is for required, state what we need to find. A is analysis, that's kind of like the brainstorming section, and we'll do our planning there. The first S is for solve, and that's where we do all of our work. And then finally, the statement will be where we wrap things up. Now, if you know how to tackle any problem, we usually skip all that stuff. It happens in our brain, and we start right there. Right? So this is only if you have trouble getting going. If you have trouble getting going, then we're going to use the GRASS method. So state what's given in the question and draw a diagram if possible. So what's given in the question? Well, we've got a tub of batter. So the tub of batter looks like a box, I guess, or a tub. And we've got the dimensions are 60 centimeters and 40 centimeters and 20 centimeters deep, I think. Is that right? Yeah, 20 centimeters deep. And this is going to be filled with batter that we're going to make into Christmas balls. And The Christmas balls are, well, they're a sphere, right? And this is 1 inch in diameter, right? 1 inch across, right? Is that right? 1 inch, yeah, 1 inch wide. What else were we given? That they're 50 cents each. And so how many ever of those these we can make out of that, we're going to charge 50 cents each. And we're going to assume that we can sell them all. So what do we need to find? We want to find how much money we can raise, right? Money raised. That's what we're asked. Well, what are the things that we're going to need to do? This is the brainstorming section. Well, it's not surface area. This is a volume problem. We need to find the volume of the tub, and it's a rectangular prism. Look up a formula if you don't remember, but it's length times width times height. We're going to have to find the volume of the spheres, right? That's a formula we're going to need to use. And if you don't remember it, look it up. You've got it. It's in the back of your book. Then what's the next step? Well, we got to figure out how many pastries we can make, right? So we're going to take this measurement and figure out how many balls we can get out of it, right? Wrong number. Where was I? All right. Yeah, we got to figure out how many pastries we can make by taking the tub, divide by the ball, and that'll give us the number that we can make. And then we'll figure out the cost by taking the number and then just multiplying by 50 cents a piece, assuming we can sell them all. When I was going through the givens, there was something, though, that I saw, and hopefully you saw it too, right? This unit is in inches, and this unit is in centimeters. So we're going to need to convert one of them, right? Convert units so that they'll talk to each other. Probably, since we've got a whole bunch of measurements in centimeters here, it's probably easiest if we use the centimeters to the inches to centimeters. And so we're going to need some sort of unit conversion there. And all of this would be, if you knew what to do, all this stuff would sort of happen in your head. And then the solution part, it would all sort of just come out. But these hard problems, I think it's a good idea to have a little planning. And so if I look up in the back of the book, the back of our book, remember there's a bunch of those conversions right in the back of the book. I see that 1 inch was 2.54 centimeters. Okay? And so I'm going to use that fact to help me out. And now, in the solving part, I'm going to just use my plan. My plan was, okay, first of all, let's find the volume of the tub. So this is the tub. Volume here is, length was 60, width was 40, and height was 20. And I fire all these into a calculator, multiply them all up, and I get a volume of 48,000 centimeters cubed. There'll be some times in these problems when you want to find surface area or something else. Lots of different problems we can be asked to do. Now the volume of the ball is pi r cubed. 4 pi r cubed. Wrote it down there and then goofed it up. I've just noticed a mistake on my notes that the radius, I wrote it down as 2.54, but that's all the way across that ball. So I got to go 2.54 divided by 2, which is, well, I'm going to have to do that on my calculator now because my notes are goofed up. So 2.54 divided by 2, should have been able to do that. I had 1.27 centimeters, and I converted that, right? 1 inch is 2.5 centimeters. I didn't use 1 inch there. I used 2.54 centimeters. And then I pound that into a calculator, and I'm going to have to do that too because my notes are incorrect. 27 cubed over 3 careful on your calculator. 4 times pi times 1.27, and I've got a cube button, so I'm going to hit my cubed, and that just does the cube of 1.27, and then I go divided by 3 is the volume of a sphere, and I get 8.58, and that's centimeters cubed. The next step, well, we've got that much batter, and each one is that much batter. So how do I figure out the number? The number is just the tub, 48,000, divided by 8.58, and I get 48,000. A lot, I think. It's a lot of Christmas balls. 5,000 Christmas balls. 5,594. We'll round down and throw the rest of the batter away, I guess. 5,594 about. And then the cost is 50 cents a piece, assuming we sell them all. 50 cents a piece. This will be how many dollars we raise times 0.5 over almost 3,000 bucks. That's a pretty good fundraiser. 270, $2,797.20. $2,797.20. Then the statement. Is it we or they? They would raise okay. I know we're getting late in the video, but this last one's going to be a quick one. Lots of words, but quick. So this will only be a few more minutes. And I'm not going to use the grass method. Again, the grass method is just to get you going on tough problems. If you're stuck, use the grass method. Mr. Faber wants to contribute to the fundraising program and suggests dumping a bucket of sawdust into the batter. That sounds like Mr. Faber. He's practical and also looking to get rid of some old sawdust. Why not sell it in batter? He also suggests that the slightly altered recipe may be not quite as good, so they should sell the new pastries for a little bit more. So 10 gallons of filler in there. We're going to lower the price. The question is, will they make more money if they choose to do this? Well, and I'm not going to use a grass method. There's a new total volume, right? The total volume was the 48,000 in the pastry tub from Mr. Elliott's class, plus the 10 gallons, right? Now the problem is that 10 gallons, we don't know how much that is in centimeters cubed, right? This was in centimeters cubed. We need the 10 gallons in centimeters cubed. Well, how do we do this? Look it up in the back of your book, right? In the back of your book, there's a whole bunch of conversion factors. 1 gallon is, in the back of the book, is 4,546.1 centimeters cubed. So how much is 10 gallons? I just go 10 times that. 10 times this, 10 times that. So that's 45,461 centimeters cubed. So this 10 gallons then in centimeters cubed is 45,461 for a total of 93,461 centimeters cubed. And notice that about half of the new recipe is sawdust, so that's real nice. And then our next step was to divide, right? We're going to take our new total volume, divide how much for 1, and how much was it for 1? I've forgotten. It was 8.58 right there. That was the volume for 1 Christmas ball, sawdusty Christmas ball now. And that number is 93461 divided by 858. Now let's clear. 93461 divided by 8 decimal 58. Lots of Christmas balls. 10,000 Christmas balls. 892, I think it said. And again, even though that's point whatever, we're not going to round up because we're just going to throw away the extra. Okay? And so that's how many Christmas balls we can make. And now the cost, how much we're going to raise, is times 30 cents cheaper times 0.3, $3,267 and a few cents, 87. And is that more? I think it was, right? Even though we've got sawdust in the recipe, we're making more. So yes, indeed. And we could subtract those to figure out how much more. Yes, Mr. Faber's Christmas balls would make more. If you can sell sawdusty Christmas balls. Okay, that's it. Good luck on your homework. These are tough problems. Be patient. Help each other out.